So just some quick denotation, I suppose, for circuits. The symbols that I'm drawing on our circuits, basically, the one that looks like a big bar over a little bar is going to be our voltage source. That just tells us where the source is coming from and how much it is. And then the squiggly looking line, like the heartbeat line, is going to be the resistance. So we can see here in blue, that's going to be our resistor. So in this explanation of Ohm's law, I just have a really simple circuit here. We have a voltage of 5 volts and a 200 ohm resistor. So the way Ohm's law works, or what it says really, is that if we have any knowns of a circuit, either like the voltage or the current, for example, we can find that third value. So in this scenario, we have the voltage and the resistance, so we can find the amperage, which would just as simply, oh my goodness, would just as simply be just like this, and then you move the 200 over, and then you get an amperage over 200, whatever that is. I'm not a mathematician. So in a parallel circuit, it's a little bit different from what we call a series circuit. As you can see from our experiments that we did before, parallel circuits actually have some different properties, such as the voltage staying the exact same over these two resistors. But you may ask, what about the current? Current's actually what changes in a parallel circuit. As the voltage comes across these two wires here, the amperage pretty much gets split between those two. Even though electricity likes to take the path of least resistance, let's say this resistor is 100 and this resistor is 50, there will still be some voltage wanting to run from the power source to this 50 ohm resistor, even though it'll be a lot less. But yeah, it's a little bit different from our series resistor, or a series circuit, in which if we didn't have this 100 resistor at all, we would have all of our power running to our 50 ohm resistor, therefore making voltage drop rather than current. Current will stay the same throughout our series circuit. Especially in a parallel circuit, our total resistance isn't going to add up the way you think it is. You see, resistors actually, whenever they add up in parallel, are going to be the 1 over themselves, but inverted. So you can see by this formula, we have 1 over 100 for this resistor, plus 1 over 50 for this resistor, and then we're going to take that entire thing and we're going to invert it, which should calculate out to a whole number. However, in a series circuit, we can see that our resistors are going to add up directly. Since the voltage is going to run through this first resistor and it's going to come down to this next resistor, we don't have to think about it in terms of a parallel circuit where the voltage may come to this 100 ohm resistor and the voltage may come to this 50 ohm resistor.
One common application of Ohm's law in our day-to-day lives is in domestic household fan regulators. Fans have variable speed, which is controlled by the regulator circuit, which I've drawn here. See, it looks like a ordinary, series circuit with one resistor, voltage, and a flowing current in one direction. But this resistor is different from any circuits in that it is the resistance inside it is variable, which allows more or less current to flow through the circuit. This specific type of resistor is called a potentiometer and is found on many different types of domestic household fans today. And changing this resistance causes the fan to go at a higher speed or a lower speed,